Hi, so my name is Hannah Hagler, and I am going to be teaching / explaining 3 prompts for you on exercise physiology. So in this video, we're going to do essay prompt number 1, which states, imagine you are a sports scientist who is consulting with a high-performance coach for a group of elite long-distance runners. These athletes compete in ultramarathons that are 50 to 100 miles in length. The coach is wondering why you're having her athletes consume carbohydrates during the race and long-distance training. Explain to them how a simple sugar molecule can create energy and fuel repetitive muscular contractions. So, let's start off from the first thing comes to our mind. When you think about long-distance running, you want to think, is it aerobic or anaerobic? Well, in this case, it is aerobic. A sprint would be anaerobic, but for such a long distance training, it would be aerobic. So when you think of aerobic, if you know anything about exercise physiology, you immediately go to fats. Why wouldn't they consume high levels of fats? They do. They do consume fats. Don't take that away from the prompt. But she's questioning why they're loading up on carbs. So carbs essentially fuel the body with glycogen. Glycogen is stored in your muscles and helps you perform better, especially for high intensity. Not having enough carbs or cutting out carbs in your diet, especially for training, it'll completely make you feel fatigued. You'll burn out. Your body cannot run on high intensity on fats alone. So, in essence, I'll turn this way since I'm right-handed. Carbs you need for a PCR system. But why and how? So fats, you'll eventually have a burnout. That's why carbs come into play. So carbs, essentially, you can think of it as a kickstart. Let's draw this out. Your athlete is running, say, 50 miles. And they're treading along. Here's the start. Fats are going to be primarily around the middle, but when they first start, I don't know if you can see all over here, hold on. So as I was saying, I didn't know if I was cut off. Your athlete will start on carbs. They'll start running, they'll have this boost of energy, they're ready to go, they have their adrenaline. So they're starting mostly in PCR with carbs. As they're running, they're getting more and more fatigued. So their body system is going to fats to help fuel the long distance run that they have. Well, there's going to be a point where your runner says, oh shoot, I'm out of energy. Their body is going to resort to the carbs that were stored. This is when your body goes, hey, you should resort to the carbs that are stored in your muscle. You get this cycle, which I'll show you in a minute, that gives you more ATP, which results in more energy expenditure. So you'll get this expenditure of energy, especially if you consume carbs while running. So like, take a bite of like a, this little carb bites, but they have protein in them. I digress. So when you get that spark of energy, it pushes a strong muscle contraction to keep going farther to get to your 50 miles, and you go back into fats for that next long distance till you need another spurt of energy, muscle contraction, and more ATP. So that initially answers our why question. What about the how? So I'm going to break this down into a little bit of simpler terms for process of glycolysis because you don't need to know every single step for this question, but I'm going to show you the main steps. So during glycolysis, your body has been running in fat. Then it says, oh shit, and turns to glycolysis. Here's what glycolysis essentially is. So you have a glucose molecule, which combines 6 carbon atoms, okay? So you have 1, 2, 3, 4, 5, 6. These are your carbon molecules. So it goes through this step of glycolysis, but the important part that we need to know is that these 6 eventually, at the end of this process, go into 2 molecules of a thing called pyruvate. Pyruvate is essentially 3 carbon molecules. So these are pyruvate. I'm gonna butcher spelling this. Pyruvate. There we go. And 3 carbon per pyruvate. Why is this important? Well, one of these 3 carbons is going to go into lactate. But hold on, there's more. These 3 can actually be converted to energy. And you can actually get 2 ATP. They're hydrolyzed to provide energy. And in the next step, which is Krebs cycle, you start to gain more ATP with a total of 4. So, this is the system that your body's going to run when that oh shit button happens during your run. Okay, so once you've reached that pyruvate is going to go and turn into acetyl-CoA because it's going to lose a carbon. Then you'll have 2 carbons. Acetyl-CoA happens, which is the hand stamp into Club of Creds. Shout out to Dr. Hyde. I'm going to use it now since I'm the professor today. And etc. So this is where your fats are going to be used. So in conclusion, fats are a slower fuel, so it takes longer, unlike glycolysis, which is a fast fuel source. And it doesn't provide the same amount of energy per unit of time like a carbohydrate does. So that is why a carbohydrate would be recommended for your marathon runners. I hope you learned something and I hope I explained it fairly well.